the VPWS and VPLS. In layer 2 VPN services, the service provider simulates point-to-point layer 2 connection, which is, we call it as VPWS, point to multi-point or multi-access layer 2 connection for the customer, which we call it as VPLS. VPWS is point-to-point, VPLS is point to multi-point. So if service providers VPWS for customer, what does this edge device think? They think that they are connected to an Ethernet switch. No. They are connected to a cable back-to-back, isn't it? If it is VPWS, they are connected to a cable back-to-back. The CE devices thinks that they are connected back-to-back with a cable, like an Ethernet cable.
Right.
If it is VPLS, the customer edge devices will think that we are connected to an Ethernet switch, because the service provider simulates an Ethernet switch for the customer devices. So this gig Ethernets that are connecting to the customer, look at there, G2, G3, and all the provider edge that connects to the customer, they may be in a different city, different country also, even different continents. Yeah, but still, the end devices, the customer devices think that they are connected to an Ethernet switch. Now, we are not going to focus on VPLS immediately. First, let us do VPWS, which is also called as cross connect or X connect. X connect or cross connect.
Okay.
It's very easy to configure, which we have also seen in our previous class with the iOS router. We are now going to do on the iOS XR router. So before I proceed further, I would like to bring up this provider network with AGP protocol. So I'll start from CSR1, which is called as PE1. And then I say interface loopback 0, IP address 10.0.0.11. Right, I would like to run OSPF as the IGP protocol, IP OSPF1 area 0. There is no difference in this configuration. Same like your iOS, but this is a iOS XE image. Next, interface G1. No shit. IP address is 10.1.1.1. Do 24 works? No, we have to type the mask. 255.255.255.0. Okay, IP OSPF1 area 0. Done. Next is MPLS. Right? Show IP OSPF interface brief. Look at this OSPF is running. MPLS IP. MPLS. Okay, that's it. Same like iOS router. There is no special command. Just MPLS IP as usual.
Do you want to turn MPLS on the G1 interface also?
We have to. In some versions like XR, we need to say some label distribution, something like that. But in this, we don't need. Let's verify show MPLS LDP interfaces. Show MPLS LED, show MPLS interfaces. You can see it is operational. That is important. It is working. And like iOS router, even in iOS XR, LDP gets enabled as you enable MPLS. Now let's move on to the middle router. Or let me do CSR2 before. Let me use a notepad because it's similar configuration 3 times. Enable config T interface loopback 0. IP address 10.0.0.12. Interface G1 10.1.2.1.
How about no shot?
Yeah. MPLS clean.
Under config T, well, no, under config T, why don't you put MPLS IP?
Yeah.
That's good.
So let us verify show MPLS interfaces. Okay. Show IP voice brief interface. Okay. So similarly, I'm going to do CSR3, which is T3. Oh no, I made a mistake. I should have said 22, but instead I said 12. It is okay. Let's make it as 12. And this one I'll make it as 13 and 14. Okay. So we are doing this for P3 now. P3 will have 30 and then we'll get 3 masks. On this, it's going to be 3. That's it. MPLS, show MPLS interface. Oh, it's not operational. Why? Okay, it is operational now. It took some time for the interface to come up.
Right.
So, show IP voice with interface brief. Nice. Now, one more router. Put in here. And this is going to be 4. All right. On E4. Show MPLS interfaces. Here come. Show MPLS, show IP voice brief interface. Okay, it is down. The interface is down, so only when the interface comes up, you can. Okay, now if you check, it will be operationally up.
Yes.
Voice brief is also waiting state. Nice. Now one more router, which is in the middle. I would like to put a loopback there as 15, in the middle row. And then on G1, G0/0, it's going to be 1 dot and then G0/1 is going to be 2.2, and then G0/2 will be 3.2. G0/3 will be 4/2. Okay, so it's all copy, put it on. So now I'm expecting 4 OSPF and 4 LDP neighbor. One neighbor is already seen. OSPF, 2 neighbors of OSPF, 3 neighbors of OSPF. One more. Show MPLS, the LDP neighbor. Show IP OSPF neighbor. Okay, OSPF neighbors are good. LDP will come, once reachability between the loopback seen, only then it will come. So why? Okay. Show IP OSPF interface brief. Show MPLS interfaces. All right, then why I'm not able to see neighbor? Oh, it has come. Took some time, but it has come. Show MPLS LDP neighbor. Okay, it took some time to negotiate and it has come up. I can see a neighbor with 11 and 12 and 13 and 14. 4 neighbors. Next. We got MPLS in place. So I can start now VPWS. Listen carefully. We are going to form VPLS between R6 and R8.
Is it recording?
Yes. We are going to form VPLS between R6 and R8. R6 it's a customer in the left. R8 is customer in the right. Okay. So let me on only those two. So as for now, I'll just pull this down. Our 2 participating routers are 6 and 8 only. This is of customer. All right, you can call this as CE routers. All right, I'm going to use the notepad here. You see, enable config the interface loopback. On the customer side loopback, I'm going to have 178.6.6/32. This is like a LAN network, okay, behind the R6. Let me paste this. This is simulating LAN network. I'll put it in a color green. I want to ping between this LAN to verify later. And I want a layer 2 connection between R6 and R8, meaning in the R table of R6, I want to see the MAC address of R8. Makes sense, right?
Yes.
I'm going to put 8.8 here. Okay, so I'm going to, okay, let me first finish this. IP address 192.168.0.8, 255.255.255. If you notice the service provider facing interface of this customer on both R6 and R8 are in same subnet. That's why we want what? Layer 2 VPN.
Right.
Customer edge 2 is for customer edge 2. And I want to run EIGRP. Router EIGRP 100. Networks or 172.16.
68.
16, sorry. A private network. So it doesn't matter here, but just want to make it real. Okay, so this is 1600 and the network. All right, we paste this on CSR3. Oh no, R8.
6.
R8. Right. So now if you notice show IP EIGRP interfaces, you should see two interfaces. But there is no neighbor. You don't see any neighbor. So for no neighbor discovered via Ethernet 00. Show IP EIGRP neighbor, no neighbor. Fine, that's okay. You know, the layer 2 circuit should come. VC should come up between CSR1 and CSR3. Only then you will be able to form neighbor. The tunnel is not ready. The layer 2 tunnel, VPWS is not yet ready. Okay, so going back to the notepad, here, this is going to be.
Wait.
Oh
Why did you
no.
put that on router 8? Exactly. That should be on router 6.
Yeah, it's okay. Now what I'll do is I'll just go and change to 8.8 okay. On router 8, interface loopback 0, IP address. I'll say 8.8. Okay. Now.
And the interface E0.0. What's that there?
Wait.
Oh yes.
See, it has picked the router ID like OSPF. I need to go change it to 8.8. Otherwise, it will conflict with that router. Router EIGRP 100. EIGRP router ID is 172.16.8. Show IP protocol. Okay, now it's changed. Fine. Now there is no other mistake we did. Let's go back to Notepad. Here this is okay. This is going to be 6. This is all okay. And this will be CE1. Okay. So on both the side, customers are ready to use the service, but the service is not yet ready. Show IP IGRP interfaces. Okay, good. Show IP. That's it, nothing. I want to check. Now, show IP, IGRP, neighbor, no neighbor. Now, the tunnel needs to be up. Let's make the tunnel up. On the CSR1, the interface that is facing the customer is what? Interface gig 2. I'll go to the interface and say, hey, I'm not going to give you any IP address. See, in CSR, you have to do this. In iOS, we didn't do this. You remember? We didn't do this. And bring the interface up.
Right.
And very important is you need to create a service instance. Service instance. And this number that we are going to provide here is important. It should match with the remote router also. Service instance 5. Let's say 5. And what type of traffic? It's Ethernet. Ethernet, for Ethernet traffic only, I'm creating this VPN. Okay, now encapsulation, if you in case have a switch instead of router 6, if I have a switch and have a trunk link, then I'll say .1q. But right now, we don't have a switch. So I'm going to say no tagging, no .1q. You understood? Next. L2 protocol forward. I just want to send CDP on this interface for discovery. All right. Next, very important thing is coming. Exit from here. See what I have done so far. Let me show you. Show run interface G2. This is what I did. I created a service interface. These are all default. Don't worry about this. I said no IP address, and I created this 3, and I created a service instance called 5. And I'm going to call the service instance, instead of calling the interface, I'm going to call the service instance, which has got the interface in XConnect. We are going to do XConnect now. Now, this is iOS XR. It's not iOS. So the commands are not under the interface. XConnect configuration commands are not under the interface. We just create the service instance and we come here and say L2 VPN. Okay? If you see, there is an XConnect here. All right? Context.
Yes.
Give any name. Now, it's a virtual context, layer 2 context, layer 2 switch that a link that you are trying to create. So give any name. I'm going to say VPWS, some name, VPWS between CSR1 and 3, some name. Now, who is the member? Who is going to use this interface? Or who is going to use this, the XConnect service? Member. The member is gig 2. In the gig 2, the service instance that we are trying to use is 5. When I say service instance 5, what does that mean? Untagged traffic. I want to say something, which I made a mistake earlier. I said the service instance should match on the other side. No. It can be different number on other PE router. That 5, when I say service instance 5, I mean the packets that are expected on that G2 interface are untagged interface, and you can provide CDP packets. That's the meaning of this. All right, next.
Do you have to provide CDP?
Yeah, to discover the remote device through the tunnel. Now, member again. Listen. Who and who need to connect? G2 of CSR1 need to connect to CSR3. Yeah? You don't need to say
Perfect.
G2 of CSR3 on CSR1. Instead, you say the remote member is 10.0.0.13. We always use the loopback, okay? And give the VC ID, virtual circuit ID. You remember we used this one. But we did all this thing under the physical interface. But now we are doing under the L2 VPN Xconnect context mode, right? Xconnect context mode, we are doing it. So the member, the remote member is this guy, CSR3. And you need to provide a VC ID. I'm going to say the VC ID is 2005, something like that. And encapsulation type is MPLS. Boom. All right, now you might have even in the STLS lab we saw the same output on the iOS router. Now, if I type show Xconnect, VC show Xconnect interface G2 detail, I can see the local label is given, but the remote label is unknown. And this is the virtual circuit ID. This is the remote guy. This is the local interface. This local interface need to use the service instant called 5, where there is no tagged traffic and CDPs are allowed. And the remote guy will come with a label, and the remote guy to whom you are going to negotiate is 10.0.0.13. There's a circuit ID that should match on the remote PE. Let's go to remote PE. Here it is. Sorry. Interface again G2. This is a customer facing interface. I say no IP address, no chat. Yeah. And then very important is service instance. Any number, I'm just giving the same number for consistency in case if I need troubleshooting. And then encapsulation is untagged traffic. I can allow the L2 protocol, which is only CDP. I do not want any other protocol. And then layer 2 VPN is Xconnect. Context, give any name. I'm going to say VPWS between 3 and 1. Name can be different. Member is Gig Ethernet 2. Service instance is 5. Remote member is 10.0.0.11. 2005. Encapsulation MPLS. The 2005 should match. All right. And I can see sudo
2005 is a VC ID.
Yeah, VC ID. Now you see there is an LTP neighbor with the remote box CSR1. If this is up, then when I type show Xconnect interface G2 detail, I should see both sides up. This is somewhat similar output which we saw in our previous class.
Right.
You can also use this command show L2 VPN and L2 VPN. Okay, this is any transport, so it includes L2. Means it includes VPWS. So let me say ATOM. Yeah. Any transport over multicasting. Sorry, MPLS.
Oh.
Any transport over MPLS. So virtual circuit ID. Okay, here it is. VCID 2005. Here also you can see the status is up and it is point to point. It is VPWS point to point. VPWS means point to point. And now I'm going to copy the same command and put it on other CSR1. And I can see here similar output.
Nice.
You can also type the keyword detail, no detail. Okay. Okay, here it is there. Detail. To see more detailed information, you see the virtual circuit ID is this, and I'm in PE1. The destination is 10003, and the label stack is 2323 is the VPN label. This is the local label. This is the label given by iOS router for 10.0030. If you want, you can go and see an iOS router. Show MPLS forwarding table. And if you see for 10.0013, the label is 18. That's what you saw here. And the next stop is the iOS router 10.1.1.2. Okay, so all these things, you can go through it later. AMTU, blah, 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 ether types, everything is clear. Okay, now we can also verify by pinging from router 6. Let's go to router 6. Or if you see the neighbor EIGRP neighbor, then it is good. Show IP EIGRP neighbor. Oh, you see who is this? It's this guy, router 8.
Yes.
So this R6 can see R8. Show IP R. Show R. You can see this. This should be the MAC address on router 8. Let's go and check. Router 8. Show interface Ethernet 0/0. And if you see the MAC address here, it is 8000. CC00 8000. CC00 8000. Exactly the same. All right, so well and good. The EIGRP neighbor is seen now. If you check the routing table, I should see the route to reach the remote site. I'm going to trace the route to this, and it's going to go through the VPN, layer 2 VPN. So you won't see many hops. It's layer 2 VPN. You're going to see just only one hop. Just one hop, which is 192.168.0.8. That's it. Boom. You see? So the middle ISP is seen like one back cable, and these two R6 and R8 fields that they are connected back to back. You understood the meaning of it very well, no? Okay.
Yes.
So that brings us to the end of the VPWS. Now, next, what we are going to do is VPLS. All right. So on the same CSR1, you can also have VPLS. So VPWS we did between R6 and R8. I'm not going to include R6 and R8 for VPLS, okay? I'm going to just off this one. This is not needed anymore. I'm going to off this. Before that, let me save the configurations. All right, so I'm going to on the other three routers, which we are going to do VPLS. We need to ping between these three routers, and we want to see in the ARC table the MAC address of other two remote sites. So that proves that we have a bridge in between. The bridge in between. So this may be in Hong Kong, this may be in Istanbul, this may be in Madagascar, in different continent, in different countries, in different locations. But still, these three routers feel as if they are connected to a very large bridge domain, very large layer 2 switch. You see, you can use XConnect, but in a large scale, it is not advisable. When there is many provider
Why?
edge, you need to provide different circuit. VPWS I'm talking about. VPWS, which we just did, is end-to-end, back-to-back. Then you need to create
Right.
many back-to-back circuit. So,
Not scalable.
yeah, not scalable. So the provider edge devices, when there are too many, and if you want to connect the customers, lot of customers, VPLS you can use, and we can use MPBGP to automatically discover the PE router. Listen, so far we did not bring BGP into picture,
No.
but now I'm going to bring it. The reason is I have many PEs. See, in our scenario, we just got 4 PE, but assume you got 400 PEs. You cannot manually say the PE.
Exactly.
So we need a protocol to discover the PE for us. So we are going to use MPBGP to automatically discover the members and the customer side. And then the virtual circuit can also get created automatically. So BGP is going to take care of the label distribution. Or because we have already enabled the MPLS, we can suppress the label distribution. We can use BGP only for P device discovery. That's what I'm going to do. I'm going to suppress the LDP via BGP. I'm simply going to use BGP for discovery of member. We call this method as Compella. You remember? Kompella. Compella.
Yes.
All right. We're going to do Compella now.
It is Compella or Martini?
This is Compella. Martin, we just did.
Oh, Martini is VPWS. Okay.
Yeah. Compella. We are going to use BGP, more precisely MPBGP for neighbor discovery. Jesus. So how do we do that? Address family. Address family is what we are going to use to do neighbor discovery. So by enabling address family, auto discovery is possible, and also the LDP. Yeah. So we are going to use BGP as a signaling protocol to discover neighbor, just for the signaling purpose. All right. So let us do one thing. First of all, let us go to the customer side, configure the customer using Notepad. On customer side, this is going to be 10. This is going to be 10. And on the loopback also, this is going to be 10.10. So this is what they planned, and I'm going to bring this up first. This is Ethernet. Okay, this is Gig Ethernet. In this router, it is Gig Ethernet G. Okay, and then EIGRP. This is fine. This is fine. That's it. This one I would like to call it as CE3.
10.
Okay, CE10. Okay. C10. Select all, copy, put this on VPWS. VPWS. Meanwhile, I'll go to this router also. All right, so here we go. On this router, I'm going to paste this. Done. So the customer side is ready. One customer site is ready. And now for router 7, this is going to be 7.7. And here this is going to be 7. Is there any change needed? No.
No. Wait. I think that one is an E. E0.
Very well said. E0. And this is should be 7. Yeah?
Yes.
Now let us paste this here. And now one more CE is there. This is going to be 9 here. And this is going to be 9.9 here. And let us make the host name 9. Okay. This will go on route 9. Done. So what is needed is to from neighbor show IP EIGRP interface we have, but show IP EIGRP neighbor no. To from neighbor we need a switch in between. So our next move is to create a L2 VPN VPLS. Are you ready?
Yes.
Okay. So we are going to make this autonomous system number as 100. Starting from CSR 1. Enable config T and then router BGP 100. Address family, no. Before that, neighbor 10.0.0.30, remote AS 100.
The 13.
Yeah, here, this one. Oh, that's not needed. Fine, I'll remove that.
Exactly.
I'll remove it. We don't have anyone there.
Exactly.
So 12 and 14.
14.
12 and 14. And update stores loop at 0.
So what about router 10?
Where is your
That VPLS router.
That's not needed. What you want that?
The VIOS.
Why we need that?
I thought it was part of the
Oh yeah,
the diagram.
I'll come there. I'll come to that
Oh,
one.
okay, okay.
See, IBGP can be to form IBGP. To form IBGP, do I really need a BGP in the middle?
No.
Not necessarily. We are going to form VPN, right? Pay attention. That is very
Yes.
important. Why I should enable BGP here? Not necessary.
No, that's not what I'm saying. That's not what neighbors.
Yeah, we are not forming neighbor with that.
Okay.
Okay, now let me go and repeat this IBGP configuration on R2 and R4. Router BGP 100. Neighbor is 10.0.0.11.
It's already up.
Update service loopback 0. And next is okay, so what is next is neighbors. Peter. All right, we need to come back again to activate the VPN, so I'm just leaving like that. I'm going to now CS2. Router BGP 100. The neighbors are 10.0.0.14. Remote AS is 100. Update source is loopback 0. Neighbor 10.0.0.11. Update source is okay. Now, wonderful thing is the IBGP is formed. Yeah, we are seeing two PEs. Now, next is I need to enable the signaling protocol BGP. So going back to router BGP 100.
All right, I have a question.
Yes.
Why do you say signaling protocol?
Because
What does that mean?
BGP, the TCP protocol, BGP, is going in between these three PE routers. That signal, that packets will make the bridge to get discovered. You will see the configuration later. You will see how this BGP keep alive, acting as a signaling for finding the bridge groups, finding the tunnel endpoints, finding the L2 multi-point VPN. You understand?
Okay.
You see now. You see now. Now I'm going to say address family L2 VPN VPLS. This command is not there in iOS, okay? So you have to come to this XR device to do this. And we need to say, I have a neighbor called blah blah. Activate the blah blah. And I got another neighbor called this guy. Activate that guy. And then I'm going to say, don't send any LDP signal because I'm using BGP. So suppress signaling protocol LDP. Also for this guy. suppress signaling protocol LDP. All right.
So it's not using MPLS then.
Say again.
Well, if you suppress LDP, does it mean you're not using MPLS?
MPLS is there in the underlay. We do not want to over the tunnel. This is for the tunnel, right? It's L2VPN prompt, right? Address family. I mentioned L2VPN. Not necessary.
Yes.
BGP itself will give the labels. And BGP keep alive itself will be used as the signaling protocol.
So we would have one label there.
Yeah. And also, whatever the MAC address that I'm learning, I want it to be reflected. So I'll say route reflected client. All right. So do I need this? If it is needed, I'll come back. If route reflected client is needed, I'll come back later. Okay, now as of now, this is enough. I want to check something, do show run. I want to see whether the extended community is enabled automatically. Show run section router BGP. Hey, no, I'm not seeing what? I'm not seeing the send the community board, send the community command. So I need to mention that also. So to this neighbor, send the community extended. Send the community is also okay. No need to say extended. Fine. So I'm going to repeat this similar configurations on other two routers. For that, I'm going to copy. I'm going to copy show run section router. I'm copying this portion to the notepad.
Even send community.
Instead.
Yep. Yeah. Okay.
All right. So here I go. I'm going to do this for CSR1. So enable config T router BGP 100 and this is going to be 12 and 12. Okay. Now I'm going to paste this on CSR1. And also for another router 4, I need to simply say here 11. On CSR4, I did. Okay, now the layer 2 VPN should be up. I want to check this command by typing show BGP L2 VPN VPLS all summary. You look at this, we did not learn any prefix, but VPN is up between these three devices. P4 with P1, P4 with P3 or P2. It is up. I don't need to go and check on CSR 1 and 2. I can see it from here itself. They are fine. They are doing good. right? So what is next? Next is, see, L2 VPN, VPLS IBGP peering is already formed. Now we need to configure the PE devices. PE devices have got the customer facing interface. Now on CSR4, what is the customer facing interface? G2.
G2.
So I go to interface G2, say no IP address. Okay, and there is a command called negotiation auto. Okay, negotiation is auto. And then same like what you did earlier, service instance. I can give any number. Earlier I already used 5, so this time I'm going to use 7. Ether type. And then encapsulation is going to be untagged. Same like what you did in XConnect. L2 protocol forwarding CDP. Okay, next, please focus. You're almost there. L2 VPN, VFI, what is this? Virtual forwarding instance. VFI. We did not use VFI in the VPWS. What did we use?
No. I think it's
we use XConnect. Let me put the question mark and show you.
Yes.
We use XConnect.
XConnect.
But now we need a bridge. So VFI, virtual forwarding instance. You see? And same like what you did for XConnect, you need to say context, give a name. I'm going to say VPLS between 4, 1, 2. Some name.
Okay.
And then this VPN ID is like VC ID. It should match. I repeat, what I'm typing now should match. You understand? This should match. Next. Neighbor should be auto-discovered using BGP signaling. Signaling. All right? BGP is a signaling protocol. Now, there is a locally significant VPLS edge identifier you need to give. It's locally significant. It can be same or different, okay? And this I'm giving 14. This is router 14, no? So I'm giving 14. This is just to say that the VE number can be different. It's locally significant. And then you need to give route distinguisher to distinguish the routes, layer 2 routes. Okay, so I'm going to give route distinguisher. This is also locally significant. What I can do, I can give some numbers. Let's say 100 colon 99.
14.
I'm just saying 9, so I'm saying 99. It's okay.
Oh, okay.
It's okay.
Okay, okay.
Next. Next is creating the switch, the layer 2 switch.
So we do,
Bridge domain.
we don't need any route target?
Those things are dynamic. Okay?
Oh, okay, okay.
Bridge domain, give any number. I'm going to give 7. Member is gig 2. Use the service instead. 7. And very important is this. Member. See, this is a local member. The remote members are discovered by whom? BGP, right? So I'm going to say
yes.
Members. Okay, exit from here. Members again are seen in VFI. The VFI name that I gave See, in VF5 only we use BGP to discover. Yeah, VF5. So the VF5 name. So I'm telling BGP will discover for you the members, the remote members. Local member is who? Local member is G2. I already told that.
Right.
G2. And G2 will be allowing untagged traffic and CDP.
Yes.
Now, let's go and configure the other side. Before that, I would like to run interface G2 and copy some configurations so that on the other routers it will be easy for me. Okay, on the other routers, this thing is okay. These things are same. I don't want to do any changes. And also show run section L2 VPN, no? VPN. Here, these things.
Yes.
All right, this ID should match. This is locally significant. I can give different number. If I'm doing for router 11, I can give 11, or you can leave it 17 also, nothing wrong. Route distribution can also be different number. I'm going to give 11 here. What did you say?
Yeah. Yeah, that's what I'm saying. Just make everything the same.
Okay.
11.
And then the bridge ID. Section bridge domain. I'm going to copy this and put it here. So here also here the interface for on CSR1 is 3. All the rest are same. Okay, so we are going to paste this. What is the interface name? 3. This is for CSR1. 3.
Yes.
Interface is 3, correct. This is for CSR1. All right. Okay. Here also the VFI is up. Now let's do it for CSR2. CSR2, this is 2. And I can make this as 12 if you want.
Yep.
And this is also 2.
And in 2.
I'll put this on CSR2. Okay. Now, I hope everything is good.
It's good. Everything is good. I've never seen a configuration like this. I've never seen it.
Okay. All right. That's it. That's it. That's all. There is nothing more now. Let us go and check the neighbor. All right. Are you ready? I'm on PE2. I'm going to say show BGP L2 VPN VPLS all summary. Look at this. I'm learning some prefixes from them.
If you say a show IP BGP summary, what would you say?
No, you have to say VPLS all. L2 VPN.
I know. I'm just asking.
It is going to show you normal BGP. We also have underlay BGP, right? This is what tunnel.
Nice.
We are focused on L2 VPN. So this looks good. And the other verifications are, we can say show IP BGP L2 VPN Simply remove summary. Okay, look at this. This is 11 router 1, PE1. This is PE2, sorry, PE4. And this is local. See, locally
Yes.
distributed, local networks will be what? Our next stop will be 000
0.
and high weightage.
Yes.
So what you see here is, this is the information about the customer. This is the customer information. Customer's routing table is identified as 100:11.
11.
So that's why it looks like this. And
PEID is
wait,
11.
there is one command, show L2 VPN PFI. You see, this is an excellent output. We got two pseudo wires. That's why it is called multi-point. And you see, virtual edge IDs. CE2 says I have neighbor with CE4 and CE1. Is this correct? Yes. And see the
Yes.
labels, local label and remote labels for them. Okay. So this is an excellent.
The local label. The local label is generated by who again?
Local label is generated by local MPLS LDP.
Okay. Okay.
All right. So we got
And the remote label is generated
that
by
is also
MPBGP.
generated there by MPLS, but distributed by MPBGP,
Oh
not
yes,
by
yes, yes.
LDP. We have suppressed LDP. Okay. So now let's go to the customer side. And if I check the routing table, I should see the remote sites router. Sorry, not this one. Um, this one. This is customer 10, which is here. I should see 9 and 7. Show IP route. Look at this. No. Why?
Do we need any redistribution?
No. No need.
Let's go to CSR1 and see. Shouldn't, because everything is up.
Show. Oh, let me go to 7 and see. Show IP EIGRP neighbor. Show IP EIGRP interface. EIGRP is running very fine here. And L2 VPN is also good. Let me type one command and see on CSR. CSR, show me the bridge domain. Okay. It says the bridge domain, but there is no MAC address
That's
learned.
correct.
No, there is nothing learned. I should see some MAC address. I should see the connected device MAC address learned here. Why am I not able to see? Do I need to generate some traffic? Let me go to this guy and try pinging 192.168.0.9, which is on the remote site. Well, now I am not learning any MAC address. That surprises. At least the local MAC address I should see. Via Ethernet 3, it should show via Ethernet 3. It should show via Ethernet 3 I have learned this. So let me go to CSR2 and type the same command, show bridge domain. Okay, let me go to router 7. Show IP route ping 10 from here.
same because not learning MAC address.
Not even a local MAC address, it is learning. So I'm missing something on the interface that faces the customer. I'm very sure that the interface, show IP interface brief. Aha, 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 aha. That's the reason. You see? Silly reasons. Let me also go to CSR1 and check show IP interface brief. Look at this. Same story. Interface G3.
Interface.
No shit. And CSR4. Same story. No, here it is up. Here it is up. Here it is up. Now let's go to, okay, here let us type this command, show bridge domain. Look at this. Wow, 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 wow. Look at this. This is the address of router 9. You see, you can see 9,000, okay? And it is connected via Ethernet, Gig Ethernet 2. And this is the address of router 7, connected via the remote guy whose identification number is 12. And the other guy's identification number is 11. Okay, now everything looks good. Let's go to this router. Look at this. The neighbor has come up. Show IP route. You can see the routes of the remote site. I can ping now 172.16.9.9. No problem.
Wait. There's something I don't understand.
Yeah. What did you? What do you know?
Is the customer edge router running EIGRP?
Yes, I was running. See, I enabled EIGRP.
Oh, okay.
So using EIGRP, it advertised, and you are seeing neighbor. Excellent result. All right. I would like you to spend some time on this.
Definitely.
Do some exercise. You see, this is the beauty of service provider